Okay, welcome back to the second part of today's notes, and we left off with a notation. So you've already learned this notation where f prime of x is a notation for the first derivative. Another notation that you will see a lot of is dy by dx. So let's write that out so you see that there's two ways you can read that. The first way is you can read this as reads y dy by dx. The second one that you can read it is the derivative of y with respect to x. Okay, that's really important, and I want to make sure that you understand this dy dx. It's not a fraction. It's saying something different. It reads. You can say it two different ways, and the key part here is the derivative of what it could be a different variable of y over respect to whatever's down here. So most of the time you'll see it this way, where we take the derivative of y respect to x. Alright, so the directions for finding the first derivative of a polynomial, the quick way. First we already know that our derivative of a constant would be 0. Now we have the power rule. You might hear that as people talk about taking derivatives. This is going to be called the power rule. And what the power rule is when we have a function equal to x to any power, so let's call it n, where n is not equal to 0, then our derivative of that function, so again that's the notation, the derivative of x would be, we'll take the exponent and multiply by whatever number is in front of here, the coefficient. In this case we have 1, so it would be n x, and then we subtract 1 from our exponent here, so that it would be n minus 1. So using the power rule, we will find the derivative, we'll multiply the exponent times the coefficient, and then subtract 1 from the exponent. So if you think about our exponent of x, where we have an exponent of 0, so think about what would that be? What would you have the derivative, just using the power rule here? We would have 1 times x, so that would be 1 times x, and then we would subtract 1 from 1, and that would be 0. So what's x to the 0 power? Anything to the 0 power would be equal to 1. Okay. Here, doing the power rule for x squared, we have 2 times 1, which would be 2, and then x, and then 2 minus 1 would be equal to 1. Okay. Just continuing on in this table, using the power rule, we have 3 times 1 in this case, it would be 3, and then we write our x, and then 3 minus 1 is 2. So the derivative of x cubed is 3x squared. Okay, all that seems pretty straightforward. Let's keep going and making sure everyone is following the pattern here and thinking about negative exponents. Remember what negative exponents means. X to the negative 1 would be equal to 1 over x. Just remember what that is. Where x to the negative 2, that's equal to 1 over x squared. Okay. So that would obviously be equal to 1 over x cubed. And remembering what the exponent of 1/2 is, remember that would be the square root of x. So just kind of bring all that back, our exponent knowledge. And in this case, we're going to just be taking the derivative. So this was just a break to bring back that knowledge. So if we're taking the derivative of x to the negative 1, it's best to, if it was in this form, to change it to this form, so it makes it simpler to use the power rule. So in this form, we're going to take our exponent, multiply by the coefficient. So we have negative 1 times 1, which would be negative 1. And then we have x. And then subtract 1. Negative 1 minus 1 would be negative 2. Okay. Continuing on, we would have negative 2 times our coefficient, which is 1. Okay. And minus 1 from negative 2 is minus 3. Okay. Go ahead and pause the video and try. Okay. So you should have found and filled in your chart the same way. And this is negative 3 fraction 2, if that's hard to read. Also, just bringing back some knowledge of our binomial expansion, remember that a plus b cubed, you could multiply it out as a plus b times a plus b. You could multiply that all out and simply get the answer, but remember the binomial expansion, reminder of what that can be used to help you find a binomial to a higher power. Okay, so we have 2 rules so far that we've talked about. When the f of x is a constant, the derivative is going to be 0. The name of that rule is differentiating a constant. The second one is x to the n. We also call this the power rule, and it's so it'd be n, the derivative of x to the n power would be nx to the n minus 1. So this we can also write as the power rule. And differentiating xn is another name for it. 2 more rules of differentiation. We have a constant times a function, and this makes sense if you think of the power rule. We take the derivative of that function and multiply by that constant. So that's called a constant times a function. And our last one is the sum rule. So when you have 2 functions that you're adding, in this case u of x plus v of x, you'll find the derivative of x and add it to the derivative of v. Again, this is the prime, and that means derivative. And this is called the sum rule. Okay, so a few examples before we stop here. We'll do some of these and not all of them, and allow you to practice a few of them. So let's do number 1 together, number 2 together, and number 8. And then there's an interesting one down here at number 9 that we'll do last. Okay. And then you can pause this and do the other ones after we finish these. So our first one is just using the power rule and our constant rule. We are going to just do our first part here of 3 times 5 would be 15. And then subtract x, and then subtract 1 from our exponent, so it would be x squared. Then we would add this, take a power rule of this one, and power rule of this one, and we know this is going to be 0. So we have 2 times 6 would be 12x, and 2 minus 1, our exponent here would be 1. Here we have negative 3x, so we have an exponent of 1. 1 times negative 3 is negative 3. We subtract 1 from x, so we have x to the 0 power, which would be 1. So we'll just have negative 3 there. Our last plus 2, it's a constant, so that is 0. So we don't have to write 0 there. So our derivative of number 1 is 15x squared plus 12x minus 3. Okay, let's try number 2. And let's do it the old-fashioned way, multiplying out, rather than using the binomial expansion. So we know x minus 2 to the third power is x minus 2 times x minus 2 times x minus 2. So first let's FOIL these two binomials. So when we FOIL this binomial, it's best to just use our knowledge from Algebra 2. It's the same binomial that we will have. First terms would be x times x is x squared, and then we would double the inside and outside since they're the same, so it would be negative 4x, and then last we would have a positive 4. Then we still need to multiply by x minus 2. So a couple of things we could do here. We could do the box method for this trinomial by the binomial, or we can use the distributive method. So I'm going to show the box method because a lot of teachers don't show that. And feel free, if you love the distributive, you can always do that. But just so you kind of see the box method. So the nice thing about the box method is it just collects. Okay, so it's collecting all our items here, and we just created a box. We have a 2 by a 3, and we're going to put x minus 2 here, and x squared minus 4x plus 4. So here we're going to just multiply each item and collect them in the box. So negative 4x times negative 2 is positive 8x, and 4x, and then negative 8. The thing I like about it is sometimes students make silly errors here, so the box keeps all their items together. So then we can collect the like terms in the box if we want. X cubed doesn't have any like terms. These two have like terms, so we have x cubed minus our 6x squared, and then we have 4x and 8x, which would be plus 12x, and then a minus 8. Okay, so we did all that just to find out what the function is. Now we still have to take the derivative. So go ahead and try that and pause. Okay, so you should have found the derivative of our polynomial x minus 2 cubed to be 3x squared minus 12x plus 12. This was just multiplying it out, and then we took the derivative with using the power rule. Okay, so our last two, number 8 and number 9, I just want to show you using just your knowledge of exponents that you must do that part first so you don't make a mistake when you take the derivative. So first what we do is we change that 1 over x squared to x to the minus 2, and 6 times square root of x to 6 times x to the 1/2. Then when we take the derivative, we will use the power rule here. So negative 2 times 1 would be negative 2. And then we subtract 1 from the exponent. So we have negative 2x to the negative third. And for the second part, using our sum rule, we will multiply 1/2 times 6 to get 3. And we have x to the negative 1/2. Then we want to change it back to the appropriate notation so there's no negative exponents. So then we change our derivative just so it doesn't have any negative exponents. Our last one here, we should divide each item by the denominator so that we can take the derivative. Okay, so if